This fixed resistor is actually encapsulated in ceramics. Anyone knows why ceramics? Imagine this is inside your computer and there's too much current. The resistor starts to heat up, right? It could lead to overheating, could catch fire. So the insulator, the ceramics can withstand that high temperature. So very nice. And we have got our component holder here. So I'm just going to clip it. It just allows me to just connect much better. So I want to find its resistance. What do I need to do then? I want to work out its resistance. And why? I like that. We need the ammeter and the voltmeter to measure the current and the voltage. But why? If V is equal to IR, Ohm's law. So if we know V and we know I, we could work out R using the equation V is equal to IR. There's also a mark given in the exam. There's a mark given in the exam for saying what about the voltmeter and the ammeter. Can anyone tell me?
Ammeters are connected in series and voltmeters are connected.
Yeah. So if you check the mark scheme, that's what they say. Right? Thank you. So first thing, what will I need? Yes?
A battery or some way to just...
Correct. So I have got my DC power supply here because I'll need to be able to change voltage. I could measure voltage and I could measure current. I could get R directly from the equation. However, imagine I didn't measure my I correctly. The whole thing would be wrong. So when we do an experiment like this, what do we have to do? We have to have set values for voltage, its corresponding values for I, plot a graph. So that's what I'm going to do. So gentlemen, could you connect that for me, please? And here are a few things. So these power supplies, right? You can turn it on because I can control the on-off button from here as well. So this is AC connection. I'm not going to use AC. I'm going to use DC today. So there you go. If I make a complete circuit, I can send electricity through it. However, I won't be able to measure my voltage. I won't be able to measure my current. What do I need? I need my ammeter. Ammeters are connected in series. So I've got to break the circuit so it makes its own loop like that. Does that make sense? A mark for that question, by the way. There you go. So next thing that we need to do is then voltmeter. Now, I'd like you to know that when we do connect voltmeters, I'd like to have my voltmeters like this in parallel. So this is just going to be connected across. Can you see that? All I'm going to do is I'm going to connect this across. And be honest, young man, this is the question you asked. This experiment is ready to go. And I'm going to make sure in terms of risk assessment, I'm not going to use 100 volts. I'm keeping my voltage low, right? And you can talk about risk assessment if you want. So turn that on. Got a value of voltage. And if it's too big, this is dual voltmeter. You can go from a range from 0 to 5 or 0 to 15. I've got my voltage, got my currents. What could I do? R is equal to V over I, and I could work with that. And what I can do, I can then change different values for voltage, different values for current, and so forth. Does that make sense? Yes, question. Correct. There was one mark in that question quite specifically for saying negative values. Watch this. See my current's negative here? Swap it. Goes positive, goes the other way. So you could have another set of values for positives and negatives. But the part that I really wanted to talk about was this. In that required practical, they use a different method to change the voltage. What did they use?
Would it be AC?
No, it was this little thing here called a variable rheostat. Looks like this, guys. And watch what I'm going to do today. So I'm going to connect this, right, to the top. And another one. Yes. So I'm going to show that to you because I think it was quite difficult in that question. To the bottom, top, bottom, and watch this now. So I want to have this positive really. So I'm going to swap that again. Now watch this. Yeah? And this is better because I can go in very small increments. Okay? Does that make sense? And that's it.